All right, hello everyone. Today is your, I guess, bonus video. I don't know, really, if you want to call it that. Today I'm just going to go through what we would be doing in class on Monday, Tuesday if we were meeting synchronously. So I'm just doing the warm-up that we would have done. So we have 4 practice problems. I'm just going to go through with you guys on solving. That is it. That is all this video is. So you can either watch it or not watch it. I will never know. But it's just extra practice problems that we would have done in class. Okay, so let me get the iPad open because I forgot to open it. And dum dum dum. As you can see, I'm very organized. Okay, we're going to the slide now. All right, so here's our warm up. Okay, so first section, it says solve the following equations on the interval from 0 to 2 pi. All right, so based on the interval being 0 to 2 pi, we are doing these 2 first problems in radians because it's giving us an interval in radians. So please make sure that when you see something like this, that you are answering in radians and not degrees. You would know that it was degrees if it said, like, for instance, in the second section, you're doing this on an interval from 0 degrees to 360 degrees. So those answers would be in degrees and not radians. Okay, so here we go. Just like normal solving, you're going to start by getting your variable by itself. All right, so for number 1, I only have a tangent, so and everything else is numbers. So I'm going to go ahead, I'm going to move everything that's a number to the other side of the equation. So that means I'm going to add 2. All right, that's going to cancel. So I'm left with negative tangent squared theta equals -1. Now I'm going to divide by that negative sign on both sides. So I have that negative in front of my tangent. So I'm going to divide both sides by that negative number, which is going to give me tangent squared theta equals +1. All right, now I need to take a square root of both sides because I want it just to be tangent, not tangent squared. So to get rid of the square, I am going to square root both sides. And we know this rule. Anytime you take a square root of both sides, you have to make sure that you do a plus or minus in front of the side that has the numbers. All right, so this becomes tangent theta equals plus or minus the square root of 1, which is 1. All right, now for kind of the last bit. So we want to get tangent by itself. We want to get theta by itself, so we want to get rid of tangent. In order to do that, we must take the inverse tangent of both sides of our equation. So we are going to do that. So we're going to do inverse tangent and then inverse tangent. All right, so now what we have is theta equals inverse tangent of plus or minus 1. All right, now, this is a unit circle value, so we are using our angles on our unit circle to figure this out. Okay, so we need to think, all right, when is tangent? So what angles along our unit circle do we have a tangent value of either positive or -1? Now remember, tangent is going to be 1 when you have the same x and y value. So we're looking for angles that have the same x and y value. That's going to happen at our 45-degree angles. And since it could be positive or -1, we're going to end up with 4 answers because we're going to get an answer for each of the quadrants because we're looking for all the positive and all of the negative. So we would have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. There we go. All right, moving on to the second one. All right, so this one's a bit more challenging. So a couple things that you can do here. All right, so I see that I have a sine squared and I have a cosine squared, and then I have another cosine. So we're gonna have to use some of those trig identities, right? Because I can't solve something that's two trig functions like being added together. We can't handle those, but we can use our identities to maybe get it all one trig function. So for this one, I'm looking at what I have. So I have one sine and I have two cosines. All right, so I have more cosines than I do sines. So what I'm going to do is I'm going to change that sine squared so that it's written in terms of cosine. All right, so we're going to go to our Pythagorean identity, which says that sine squared plus cosine squared equals 1. So sine squared plus cosine squared equals 1. So if I have sine squared, well, I can say that sine squared equals, so sine squared equals 1 minus cosine squared. So I'm going to replace that sine squared with 1 minus cosine squared. I'm going to wait for the writing to catch up because it's taking forever. Okay, so now that the writing has kind of caught up. So what I did, just to recap, is I replaced sine squared with 1 minus cosine squared. All right, you have to make sure that you leave that negative out front. So if you can see, I do have that minus in front of my parentheses there. But now if you look at it, everything is a cosine or a 1. And this is very good for trying to simplify and eventually maybe factor or something like that, right? So now we have, this is like having one variable, right? We basically got rid of a second variable. So this makes our problem much easier. So now we're going to go ahead and we're going to distribute this negative. That's going to give us negative 1 plus cosine squared plus cosine equals negative cosine squared theta. Okay, so just like an algebra problem, all right, where you have something squared, something to the power of 1, and then a constant, so our 1 in this case, you move everything over to one side, and then we are going to factor this. All right, I'm just waiting for the writing to catch up. Oh, it's so bad today. Okay, so as you can see, now that the writing has caught up, I moved everything over to the left-hand side. So I added cosine squared to both sides of the equation. That gave me 2 cosine squareds plus cosine minus 1. Now, we can treat this just like we would any other solving or factoring problem, all right? If having the cosines in there is intimidating to you, you can replace it with x, and then at the end, once you've finished factoring, you can put the cosine back in. So this is what I mean. So some people like to do this. You can rewrite this as 2x squared plus x minus 1. And then, all right, so we just rewrite it as 2x squared plus x minus 1, and then we can factor. So we're going to do our box. All right, our 2x squared is going to go in that top left corner. Our minus 1 is going to go in the bottom right corner. And then to find the numbers that we're going to do in the diagonal, remember you have to do the first number, so the 2 times the negative 1, and then so that gives us negative 2. And so we're looking for two numbers that multiply to negative 2 and add to positive 1, right? So it has to multiply, oh, the writing is never going to catch up. Has to multiply to 2 times negative 1, and it has to add to positive 1. That's going to be positive 2 and negative 1. So that's what we're going to put in our diagonal box if it ever loads. All right, so here we have our box. You guys don't know this, but that just took 4 minutes for that writing to load. I was counting. Okay, so from here, we're just going to basically, like, remember, we do a GCF of that top row, and then we like reverse multiply, right? We like say, okay, we know we have to end up with this. What times what will give us this, right? That kind of thing. So we're going to pull out a GCF from that top row. That's going to be a 2x. So that means x goes on top here. This is going to be a 1, and it's going to be a negative 1. All right, so our factors are x plus 1 and 2x minus 1. All right, so now that we have factored it, I'm going to go ahead and put the cosine back in. So everywhere you have an x in your factors, that would now go back to being a cosine. All right, remember this technique you don't have to do, but I know some of you guys think that having a cosine squared and a cosine is intimidating. So being able to just plug in an x just for factoring to get kind of wrap your mind around it and then put the cosines back at the end is helpful. But again, it's not necessary if you feel like you could factor this without replacing cosine with the x. All right, so with the cosines put back in, this becomes cosine theta plus 1 and 2 cosine theta minus 1 equals 0. All right, now just like any other solving that we've done, you're going to take each one of those parentheses and you're going to equal it to 0. All right, and then we're going to solve for theta. So I'm going to let the writing catch back up again. All right, so now that, again, the writing has caught up, all right, we are going to set each one of our factors equal to 0, and we are going to solve. All right, so there we go. Move that down a little bit. Okay, so we have cosine theta plus 1 equals 0, and we have 2 cosine theta minus 1 equals 0. So cosine theta equals negative 1, and cosine theta equals 1/2. All right, we do inverse cosine on each side. All right, so for the first part, so we need to ask ourselves, when is cosine equal to negative 1? Cosine equals negative 1 when you are at 180 degrees. So that would be pi. And cosine equals 1/2 in two places. All right, so that's going to be at pi over 3 in our first quadrant and 5 pi over 3 in the fourth quadrant. Okay, so let's move on to the second section. All right, so this is in degrees. All right, so for the first one, we have negative square root of 3 cosine tangent plus tangent equals cosine plus tangent. All right, so we're definitely going to try and get everything to one side of the equation. So I'm going to go ahead and move the cosine and the plus tangent over to the left-hand side. So minus cosine, and then minus tangent. Ooh, which that's nice because then that's going to make that go away. Tangent and then minus tangent goes away. All right, so now rewriting what we have, that's going to give us negative square root of 3 cosine x tangent x. And then we have this minus cosine x off to the side. The tangent's canceled, so we don't have any of those left, and then equals 0. Okay. So from here, I need to separate the cosine and the tangent. That's really the only way this is going to work. And we're going to do that by factoring. So if you notice, both terms on that left-hand side have a cosine. We're going to GCF out cosine. So we're going to pull out cosine x, and that's going to leave us with negative square root of 3 tangent of x minus 1 equals 0. All right, it's catching up. So cosine x pulled out, right? We GCF'd it. took out a greatest common factor. All right, and now, so now we have our trig functions separate. So at this point, we can set each piece equal to 0 and solve. So we have cosine x equals 0, and then we have negative square root of 3 tangent x minus 1 equals 0. All right, for that first piece, we are just going to take the inverse cosine of both sides. It's trying so hard to catch up. There it goes, almost. There we go. So we have x equals inverse cosine of 0. So this is asking us when on our unit circle do we have a cosine value of 0. All right, so that's going to happen at 90 degrees. And so we are in degrees because it's 0 to 360. So this is going to happen when x equals 90 degrees and when x equals 270. All right, now we need to find the solutions to the other part of our equation. All right, so we're going to add 1 on both sides. That's going to give us negative root 3 tan x equals 1. Divide by negative square root of 3. So we have tangent x equals negative 1 over root 3. We are going to rationalize our denominator. So we're going to multiply top and bottom by the square root of 3. So we have tangent x equals negative root 3 over 3. All right, writing caught up now. So, so we have tangent x equals negative square root of 3 over 3. Last thing we got to do is inverse tangent on both sides. So now we have x equals inverse tangent of negative square root of 3 over 3. So we need to figure out what angles on our unit circle have that tangent value of negative square root of 3 over 3. And if you ever notice this where the square root like started in the denominator, right, that means that the square root was with the x value of the coordinate because with tangent, it's y over x, right? So if we end up with that square root in the bottom, it means it had to go with the x coordinate. So you're going to have square root of 3 in the x coordinate at your 30-degree angles. But this is negative, and tangent is only negative in quadrants 2 and 4. So we're going to have our second quadrant and fourth quadrant 30-degree angles, which is going to be 150 and 330. And so those are our answers for that problem. All right, moving on over to the last one. All right, so this one is all tangent, which is nice. So in this problem number 4, it's all tangent, so we don't have to worry about switching from tangent to something else or using an identity or anything like that. We can just move everything over to one side and probably factor. That's probably what's going to happen in this one. So I'm going to start by adding 2 tan squared to both sides. All right, so now we have negative 3 plus 2, so that's going to be negative tangent squared x plus 2 tangent x minus 1 equals 0. It's so slow. Why are you so slow? Okay. I'll just pause. Okay, it's caught up now. So, what I like to do when I'm factoring, I don't like to have a negative number out front. So I'm just going to multiply through by -1, which is just going to change all of my signs. That becomes positive, that becomes negative, that becomes positive, and 0 times a -1 is still, it's just 0. 0 is neither positive or negative. Okay, now if you like that technique where you turn it into x squareds instead of having the tangent in there, this would be the step where you would do that. So we could say that this is x squared minus 2x plus 1 equals 0. So if that helps you while you're factoring, then you can definitely go ahead and do that. So now for this one, we are looking for two numbers that multiply to +1 and add to -2. So we want them to multiply to 1 and add to -2. So that's going to be x minus 1 and x minus 1. All right, I'm going to go back and I'm going to put my not cosine, I'm going to put my tangents where I had the x's. So it's now going to be cosine x minus 1 times cosine x tangent. Why do I keep wanting it to be cosine? Tangent x minus 1 times tangent x minus 1. I have no idea why I keep wanting to change this problem to cosine. Now the writing will catch up. Okay, so now we're going to take each one of our parentheses and we're going to equal it to 0. And we're going to solve for x. So tangent x minus 1 equals 0. Tangent x minus 1 equals 0. So we have tangent x equals 1, tangent x equals 1. Now we're going to do inverse tangent on each side. So inverse tangent of 1, inverse tangent of 1. All right, so we are now just looking for when do we have a tangent value of 1. All right, so when on our unit circle do we have a tangent value of +1? So that's going to be at your 45-degree angles, and it's positive, so it's going to be at 45 degrees and at 225. Yes, 225. And you don't have to do it twice, right? Because we know that it's going to be on the other one, it's also inverse tangent of 1, right? It's also 45 and 225. So you only have to write them once. If you want to write them twice, you can. But right, these two are the same, right? X equals inverse tangent of 1 is the same. So you only have to give me the one answer. Like I know that the answers are twice because they're twice. Anyways, that is it for your short little kind of extra practice problems together. Warm-ups, this is what we would have done together Monday, Tuesday morning, but since teachers are doing special training, then I can